Hi everyone, how are you doing? Good, me too. Okay, so today I'm going to be presenting S0i3 or S0ix on FreeBSD, and I'll start with a little bit about me. So I'm into like OSs and graphics programming, and I'm sponsored by the FreeBSD Foundation to work on this. And I also am a developer at Renewable, which is like energy storage solutions in Belgium. And I spend most of my time in a train. In fact, there's a running joke with my colleagues that I'm homeless because they only ever see me in a train. And yeah, so that's that. Once upon a time, a very long time ago, actually not that long ago, but computers used ACPI S3. S3 was a bit of a heavy-handed approach. You were just telling your computer, OK, go to sleep. And you know, there are other states that are still used today. So like S0 is when your computer's running, S5 is when it's off. And yeah, there's a few disadvantages to this. It's pretty slow to enter and exit, and it's pretty inflexible. And especially modern laptops don't support this anymore. So if you've got like one of the newer AMD frameworks, or even the latest Intel framework, I think, you don't have S3, and so you can't go to sleep, which is problematic for a laptop. So what is S0ix? So S0ix, you're staying in S0, and it's your platform that decides when enough requirements are met to enter an S0ix state and turn off the CPU. So the theory behind it is, yeah, you just follow some requirements, some device power constraints, and then your system will go to sleep. And so the holy grail of this is S0ix. That's what is saving the most power. That's when like everything is off. And yeah, so Ben Wadowski from Intel did a bit of work on this in 2018. With these two patches, but there was quite a bit of work to actually get it to work. So I want to start with a bit of a crash course on ACPI. I gave this talk at FOSDEM, at least this part of the talk at FOSDEM, so it's going to be pretty much the same. But yeah, ACPI is just, I mean, first of all, who's heard of ACPI? Because I feel like it's one of those things that a lot of people hear about, but don't know what the purpose of it is. So your platform exposes a bunch of information about your hardware, and it does this through this kind of configuration language called AML. And so, yeah, it's actually compiled. When you get it, it's compiled into ASL, and then when you want to read it, you decompile it into AML, and you do this with ACPI dump DT. And so here's an example for the lid device. So the lid device is just the thing that says if your laptop lid is open or closed. And you can see it has some kind of hardware ID and an object methods that you can query to know if the lid is open or not. And so this EWSL thing is just some like a register in memory, and it tells you if it's open or not. So it's pretty convenient because it means that you can just like read this AML and know like what should I read to know if my lid is open or closed. You don't have to like just happen to know the hardware address, or it's just a way to communicate what to read. And here's an example of how it's actually read in code. So this is ACPI lid.c. That's the thing that does this in C. And you can see it's just getting the integer. If there's a failure, we're just assuming it to be open. Otherwise, we get the status. If it's anything else than 0, then it's open. And if it is 0, then we assume it's closed. So I hope that gives a bit of an idea of how that works. OK, next thing I want to show is the SPMC. So with S0ix, you have something called modern standby. And modern standby is telling your embedded controller, a lot of computers nowadays have embedded controllers, that, oh, this is a point in time where I'm going to start entering sleep, and this is a point in time where I'm going to exit sleep. And so your embedded controller will do stuff like on the frameworks, it will flash the power button slowly. So it indicates to the user that you're in a sleep state. But the SPMC doesn't actually put the system to sleep. So it exposes a device-specific method. And in ACPI, this is just like a multiplex function where like the first argument is like a vendor-specific, vendor-defined number. And there's a bit of vendor-specific complication, but for the most part, the important values are get device constraints, which will give you a list of device constraints you need to respect. and then display off and entry notifications to enter, and exit, and display on to exit. Right. So yeah, D-states. So these are those device constraints. Your devices can have different power states. So D0 means that your device is on. D1 and D2 and D3-ish mean like sort of off. D3 is split into D3 hot and D3 cold. D3 hot means that it's off but still receiving power. D3 cold means that it's not receiving power. Sort of unclear what just regular D3 maps to. There's discussion with Intel about that. And yeah, to change the D-state of a device, we need to talk about power resources. So here is the NVMe device and its power resources. Every one of these PR things corresponds to a D-state. So PR0 would be D-state 0. And it's saying that it depends on the P0 NV power resource. And the way that we know that we're in a certain D-state is if it's the shallower states which have all its power resources on. Yes. So I have a little bit of a diagram to make this a bit easier to understand. So in this case, if the P0 NV power resource was off, then we'd be in D3 cold, because we're not in D0, not in D2, not in D3 hot, so it means that we must be in D3 cold. But if it was on, the shallowest one which depends on it is D0, so it means that we're on. So in this case, the NVMe device can either be on or off, depending on if P0 NV is on or off. Sometimes you've got more complicated situations, but most of the time it's pretty simple, like this. Right, so these are 2 patches to do that. And the next thing I want to introduce is suspend to idle, S2 idle. So all we've done at this point is just let the system know that we want to enter suspend, but we're not actually idling the CPU. We're not actually doing anything. And so, okay, let me read what I wrote. Yeah, our CPUs could still be doing work while we're in mod suspend, so we want to actually idle the CPUs. So the first step we want to do is bind ourselves to CPU 0. We want to stop the scheduler clock on all our CPUs. And we want to kick them so that they actually enter idle. We wake on from this idle state from an interrupts, so we want to disable all interrupts, except for one kind of interrupt, which is the SCIs, which is the way that our platform lets us know that we're going to wake up. So this could happen if you hit the power button or open the lid or stuff like that. And yeah, that's interrupt 9 usually. So we stop all interrupts and we just allow the SCI, interrupt 9. So then we actually idle the CPU. We do this in a loop because our platform will sometimes send us SCIs and events which aren't necessarily wake events. So a common example is on the frameworks, if it's unplugged, every 60 seconds it will send you a battery status update. I'm guessing they do this so that you can track battery states while you're suspended. But we don't actually want to completely wake the system. So we do need to check whether or not this event is a wake event or not. And if it's not, then we want to go straight back into idle. So that's the S2 idle loop. Now, the one issue is that when we receive this interrupt, currently in FreeBSD, we don't handle this synchronously. We add this to a task queue, and then at some point it will be handled. So we need to drain this task queue, and I'm not really sure what the best way of doing this is. Maybe it would make sense to do this synchronously, to special case the S2 idle state, and then just special case this handling, and just do it synchronously right after we get the interrupt. But this kind of works for now, although it's a bit buggy. So yeah, once we exit the S2 idle loop, pretty simply, we just resume all interrupts, so we are how we were before, and resume the scheduler clocks. By the way, if any of this is a bit unclear, please let me know. Ask questions, because yeah. All right, so just idling is not sufficient for power savings. We actually need to enter, convince the platform to enter S0ix 3. And I don't know why I put this fun fact here, but yeah, dolphins and whales sleep half their brain at a time so they can still surface for air, which is something I discovered yesterday. I think that's pretty interesting. Right, C states. So we need all CPUs to be like in a deep idle state before the platform will want to enter S0ix. And these states are called C states. So C0 is like active. C1 is what happens when you just do the halt instruction. And there's a bunch more. And yeah, depending on your platform, you could have more or less. In theory, the way that we enter this, and that's the way that I thought it worked for a long time, because that's how it's usually, how S0ix is usually introduced, is through the mwait instruction. So the mwait instruction, in theory, is just used to halt the CPU until a bit of memory is written to, and then it will wake it. But it can also be used to just halt the CPU until we get an interrupt, similar to halt. But you can also give it like a platform-specific C-state hints. So for example, you could tell it to enter C4 while it's waiting for an interrupt, and then to break out of that on interrupt. Now on AMD, that doesn't really work. So I have to do a bit of a quick detour to show you the AMD SMU. So the AMD SMU, I started writing the driver for this for debugging, mostly. It's like a small bit of the CPU. It's up here on the top right. And it runs some firmware called PMFW, and it's the guy that's like responsible for doing all the power management stuff on your CPU. And it actually decides when to enter S0ix. So this is the thing that we need to convince to enter S0ix. We can send commands to it to get like residency information. So residency is just how much time are we spending in a specific state. So that's pretty useful to know if you actually did enter S0ix or if you were just active during the idle period. And you can also hint it that we're entering and exiting sleep, which you need to do, otherwise it will never enter S0ix. So the driver that I wrote for this creates sysctls with these residency stats. So let me see if I can select this like that. Where's my cursor? There's my cursor. So this is the output if we haven't gone to sleep yet on the system. So everything is predictably 0, except for USB 4.0, which always seems to contain junk for some reason. Yeah, it's a bit of a weird thing. Right, so if we just do mwait, if we just try to idle and sleep with mwait, AMD SMU will show that the CPU was still active during this, and it will give us time spent. The time spent will entirely be in this SW drips thing. So I guess this is a bit of a misnomer. That's just how it's named on Linux, but this just counts basically between when you tell the SMU that you want to enter S0ix and when you want to exit. And then it will give you a bunch of dependencies that need to be met before it will actually do it. And so in this case, it didn't enter S0ix because USB 3.1 and USB 3.0 were still active, and the CPU was still active. So this is USB 4 related. I know it says USB 3. It's USB 4 related. I'll cover that a bit later. But the CPU is the thing that we'd like to cut down on first. And so clearly, mwait is not sufficient. That's what the SMU is telling us. We have in ACPI this CST object. CST thing gives us all the C states that our CPU supports, and also an entry method. So it just gives us like these registers, and when we read these registers, then the CPU in question will enter that C state. And there's, I guess the equivalent to this is LPIs. LPIs basically have the same thing. It's just that some newer systems don't have CSTs, and some older systems don't have LPIs. But it's the same idea. And what did I write here? Oh yeah, that's just saying that, yeah. The LPI things can contain a residency counter, but this isn't used on AMD, so let's just forget about that and use the AMD SMU. Right, all this is in ACPI CPU.c, and for some reason, which I haven't quite figured out yet, John and I theorized that it was related to S3 entry, there's this disable idle function that's called when you suspend the ACPI CPU device, which prevents this C state entry. So yeah, if we want to enter S0ix and we want to actually suspend the CPU, we need to prevent this somehow. So for now, I'm just special casing it, but I need to figure out what the purpose of this disable idle thing is in the first place. And so if we do this, now the SMU tells us the following. It says that the CPU is not active anymore, which is very good. But there is one thing that we're missing, and that's these things, the 3.1 and 3.0. These are still active. That's the USB 4 stuff. So that was a lot of work. A large part of the work of this project was actually writing a USB 4 connection manager to turn this off. So here's a bit of a quick overview on USB 4. So USB 4 is kind of this thing to tunnel other protocols. It's not like a USB in itself. Actually, when you're using USB over USB 4, you're just using USB 3.2. That's just tunneled through it. And so here you can see the diagram of the host router. This is just stolen from the USB 4 spec. All USB Type-C connectors, actually I have this on the next slide, have these middle pins here over which USB 2 goes. So any kind of USB 2 stuff will just go straight to the USB-C connector. It doesn't have anything to do with USB 4. But over here, USB 3 stuff can either go straight to the Type-C connector in the case of in fallback mode, essentially, or it can go through the USB 4 router, which can then decide to use the pins that USB 3 would otherwise use and tunnel that data over that. And it can also tunnel different types of data, like DisplayPort or PCI. Now, you might have realized that on the frameworks, even though we don't have USB 4 support yet, I mean, not for DisplayPort at least, DisplayPort and the HDMI thing will still work. That's because there's a special mode called DP alt mode, where, yeah, there's negotiation happening over the sideband pins, as far as I understand it, and then the DisplayPort signal is over these pins here, which are otherwise used for either USB 4, either PCI, or USB 3. So yeah, that's the rundown of that. Now, I inherited the USB 4 code from Scott Long, who wrote a skeleton of it a while ago. And this was transferred to HPS. And yeah, so I picked this up. I removed the ICM code. So ICMs were, that's an internal connection manager. This was, yeah, basically a big part of the driver was implemented in firmware, but this was a bit odd because every single controller had its own quirks and idiosyncrasies. So yeah, Scott Long kind of suggested to axe all of that, since anyway that's just a bunch of old controllers. And now we're just entirely using the HCM, which is the host connection manager, which is completely OS side. Now the reason why we need to do this USB 4 support is because in the BIOS there's such a thing as a pre-OS connection manager. This is just used so that USB 4 works in the BIOS. But it means that when we start up our OS, we don't have, I mean, the USB 4 routers are not in a defree state, which means that we're never going to be able to enter S0ix. So I did try one thing, is to pass the USB 4 controller to Linux guests to suspend. That just miserably failed. But yeah, so I had to start actually picking up on that code and writing the suspend routines. It turns out it wasn't too complicated. I mean, there was a bunch of code surrounding it that was a bit complicated, but the routine itself is pretty simple. Since we're not doing any links, we don't really have to worry about link states. I'm assuming they're all by default in CLD. I'm not entirely sure of that, but you know. So all we really need to do is pretty straightforward. There's a configuration space on the routers, which we can set the SLP bit in, which is sleep bit. And then we just have to wait for the sleep ready bit to be set. And once that's set, then we know that the system, the router has gone to sleep. On V2 routers, it's a bit different. We can still do it like this, but the proper way of doing it is to wait for a notification instead of just polling this bit to see when it's set. Sorry. All right. So now that we do all our USB 4 stuff and we put it to sleep, the SMU tells us the following, which is that not only our USB 4 stuff here is set to 0, which is correct. This is still garbage, I don't know why. But that we also have time in S0ix, which means that our system is actually entering S0ix. And this thing here, the last entry status is set to 1, 2. So yeah, that's that. Yeah, so I just wanted to thank Mario Limoncello because during the development it helped a lot. He helped me a lot getting like a very minimal Linux kernel built so that I could test, try removing stuff to see if it actually impacted S0ix entry on my framework laptop. And he has a script actually for this, AMD S2 idle, which I'd like to port to FreeBSD, which diagnoses reasons why your system want to enter S0ix for you. So yeah, this was pretty useful. He was very helpful, so thanks to him. All right, yeah, there's a couple more things I wanted to say about USB 4. Did I forget about them? I forgot about them. Okay. Right, testing. Please test this. You can apply each revision with argpatch, no branch. The tip of the S0ix and S2 idle stuff and the AMD SMU stuff, they're all in one big stack, is over here. USB stuff is over here. Now this is just supporting the pink sardine controller at the moment. We need to add more generic support, but right now it's just pink sardine. Pink sardine is the one that's in the 7000 series AMD framework laptops. And there might be a way to apply all these changes at once, but I don't know Arc well enough. So I also have a simple branch on GitHub that you can just clone over there and then build it as is, and it should work. Except that at the moment I just rebased it on 15, and it breaks. It kernel panics all the time. I think I found the reason why it kernel panics, but it's yeah, I haven't fixed it yet. I had this genius idea to rebase right before this talk, so. Right, so yeah, please test it on your machine. Make sure that you have S2 idle on your machine once you build all these patches. It should just work, but this is a good way to know if you've applied everything correctly. You'll go into ACPI supported sleep states, and these are the states that are supported. On older computers with S3, you'd also have S3 here. S0ix does work on a lot of S3 computers, so you can try doing that. And for modern ones, you'll just have S4, S5, and S2 idle. To actually use it, you can set the ACPI power button states to S2 idle. That means that when you press the power button, it will enter S2 idle instead of the default, which I think is shutting down, if I'm not mistaken. There's also an equivalent for the lid. So that's lid button state. And yeah, if you do manage to do all that and you do manage to suspend, please send me the D message, ACPI dump DT, and if you're on AMD, the contents of the AMD SMU. And that will tell you if you actually entered sleep or not. Currently, there's a bunch of issues where, especially USB 4 related issues, I mean, it's very buggy at the moment. It breaks a lot. There's a lot of random panics and stuff like that. And it won't re-enter sleep once it wakes. So the USB 4 router will sleep, wake, and then not re-enter sleep. I think I know why. I am in the middle of fixing it. So yeah. All right. Here is the 1/3 chance of failing demo. Unfortunately, the HDMI on my framework doesn't seem to be working with this thing. So, oh yeah, I lied to you guys. This isn't a framework. It's a Mac. It's my backup. This is a framework. So, hold on. Let me put the backlight back up. So I'm going to try to suspend it. I think it will panic. I'm actually fairly certain it will panic. But, you'll see it here first. I'm going to press this button here, and is the cursor blinking? It stopped blinking. It's not entering suspend. That probably means it panicked. So I had prepared a list of jokes to tell in the case that it did panic, so that while I waited for it to reboot and you know, I could tell a bunch of jokes. But now, since I'm just running on the backup computer anyway, I'll leave the jokes for last. You can still hear the jokes later. Yeah, that's all. OK. Oh, yeah, one thing to note also. Do you remember when you're testing to unplug your computer from AC, at least on the frameworks? Because it will, like, every second send you status updates when it's plugged in. And it will never enter S0ix. So it needs, oh, the screen went black on the framework. It's still not suspending. It's just, oh, it rebooted. OK, anyway. Future. So I haven't done anything for Intel yet. It might just work. Someone told me it works on their Intel. I don't know if that's true. I haven't had an opportunity to try it. I need to fix the USB-related panics. I mean, it's a big amount of code all at once, so there's a lot of stuff to fix and to smooth out. I'd like to be able to give the ability for users to add more complex wake rules. That's not something I really covered, but currently, so you can tell like different devices. You can tell ACPI, okay, I want this device to turn on to wake the system, or I don't want it to wake the system. So an example could be like maybe I'm plugging a device in and I want this event to wake the system or not. Currently, it's broken on a lot of modern ACPI stuff. Yeah. And the last thing is, no, the other thing is S4, suspend to disk. So this is, so S3 and S0ix, all this is doing is suspending to memory. Everything turns off, but the memory is still alive. So when you turn it back on, it just works, I guess. With S4, you're actually copying your memory to disk, and you're basically shutting down the system. And then when you wake it, you're rebooting the system, restarting all the device drivers, and then copying that memory into memory. And it's pretty good, because it saves much more power, because you're basically entirely off. No, you are entirely off. The only issue is that it takes, as you can imagine, a long, long time to enter and exit, because you have to, copy all this data in and out of disk. And so usually what you want to do is when you're in a state like S0ix or S3, you want to wait a certain amount of time. And then if the user hasn't touched their laptop in like 2 hours, you can probably safely say that in the next couple minutes they're not going to open it. So you can go into hibernate and then save more power. And then next time they open their laptop, it will take a longer time to start up. But at least you'll have saved quite a bit of power. Last thing is idleness determination. I'm not really going to go into that. Right. Another thing I wanted to highlight, there is a GSOC project that I'm mentoring this year on bringing PowerTop to FreeBSD. So PowerTop is a Linux tool which gives you a power usage breakdown of all your processes. And yeah, it would be cool to bring this to FreeBSD. And yeah, SAIC is working on this. Yeah, so this is part of the Foundation's laptop project. There's an issue tracker for all things related to this. Please do test this on your laptop if you have a chance, and send me an email if stuff isn't working, or is working. I'd also like to know what is working. Yeah, that's pretty much it. I think I covered all I wanted to cover. So here's my contact information. If you'd like to have a beer with me, or 12, you can. Here's my FreeBSD email, regular email, website, GitHub, and Discord, but I don't really use that. So yeah, that's about it. Now, would you like to do the questions first or the jokes first? Because I have a few jokes. Not that many, actually. I have like 4 jokes. OK, I'll do like 1 joke and then 1 question. So I just built an ATM, which only dispenses coins. I think it just makes sense. Because, OK, questions. Who wants to ask a question? Yes?
Does that S0ix state similar to S3 in the point that we should suspend all devices? Do we depend on all devices, device driver properly suspend, suspend resume?
Not necessarily. I think there is, I'm not entirely sure if the Wi-Fi driver, you have to completely shut it off. and if it still will wake the system, because there's a, I forget what it's called, but there's a mechanism whereby if you can make it so that if you receive a packet that's important to you, your Wi-Fi chip can wake the system or not, which could be useful if you like, I don't know how deep it really goes. I haven't really looked much into this, but it could be like maybe you receive a packet from a certain IP address, then you wake up or something like that. I don't know if you have to turn the device completely off for that or not. But either way, you have to respect the device power constraints that the SPMC gives you. And you are free to, if it tells you that you don't need to put a device into S3, you are free to leave it in, if it tells you you don't need to put a device in D3, you're free to leave it in D0 and still have it, do whatever kind of stuff you want.
But do you call all the suspend methods for all the device 3?
Currently, yeah. Yeah. But yeah, in theory, if it doesn't tell you you have to put it into D3, you can leave it in D0.
So you showed how USB 4 also tunnels PCI Express. What happens if there's a PCI Express device connected via USB 4 and is on its own power supply? Will it be also suspended, or will it hold up suspension?
That's a good question. I assume it kind of depends on the device. I mean, from USB 4's point of view, as long as you sleep the lane that is sleep the connection, then that's all your host is concerned about. I'm not sure how devices handle that, if they stay on, if they're on a different supply, or I don't know. At least I think if you're turning off the lane, it's not getting any power from the host.
Yeah. And would that be any different with Thunderbolt?
Thunderbolt is, USB 4 is, that's sort of the same thing. Thunderbolt is like an older version, I guess, that's proprietary, and USB 4 is just the standardization of Thunderbolt.
And both tunnel PCI Express identically?
Pretty much, yeah.
Okay. Thanks.
Yeah. Anyone else? Okay, I guess it's time for another joke. So I got a pen that writes underwater. It can write other stuff too, because it doesn't only write underwater. Okay. Right. Any other questions?
All right. So we have a couple questions from IRC, but
Yeah.
before I get to that question, so you had displayed the info about the laptop desktop working group, just so everyone else that GitHub is, as far as I can remember, the comments are kind of like you have to ask the foundation for comment access because reasons. So you're probably better off subscribing to the FreeBSD desktop mailing list and kind of following along to the monthly meetings. And because obviously the mailing list is the mailing list, and right. Anyway, so now we have some questions from IRC. What is still missing to support PCIe hot plug and unplug via USB-C?
A lot. The USB 4 stuff at the moment is really just enough to initialize the router and suspend it, and already that's like 7,000 lines. So there's a lot of work to be done to get to any kind of useful stuff with USB 4. I mean, for now, my main concern is just getting it to the state where it can suspend. Maybe I'd work on USB 4 in the future, but that's not in the plans right now.
All right. Okay, the next question from IRC, what's expected power consumption if you get into S0ix compared to S3 or S4?
It should be identical between S3 and S0ix. S4, the expected power consumption is basically 0. The only thing that's still running is your embedded controller, as far as I know, which is necessary for handling stuff like, when I press the power button, what do I do? So yeah, S4 is basically 0. S3 and S0ix are pretty much the same. They consume less, but not none.
All right, and then what is missing to use common USB-C or Thunderbolt docks with FreeBSD laptops?
Same answer as the question earlier. Everything. Everything's missing. I mean, we need for docks. I mean, if you want to support everything on a dock, and you want to also support like devices downstream of those docks, you need to support DisplayPort over USB 4, USB over USB 4, and PCI over USB 4, which is a lot of work that's just not existing. Yeah. Any other questions? Okay, well, I think that's about it then.